Hey guys, welcome to your homework. I know you're super pumped, but I hope you're actually listening to this. Some of our classes today if you got through this first page, just kind of skip until you see me opening up to the inside. That's where you're going to pick up. Everybody else, aka period 3, you're going to stay here with me because this is important. This is kind of the intro. We just wrapped up our whole unit, and now we're going to be talking about slope specifically. We're going to start out talking about slope from a graph, and then we're going to move into tables and points on Monday and Tuesday. We know that the slope is the rate of change. It's how something is moving over time, how it's moving throughout the graph. This rate of change can be found by doing the change in the y values, which is really just the difference of the y values, over the change in the x values, which is really just the difference in our x values. I know it's very ambiguous right now, but in about 2 minutes it's going to make a whole lot of sense. There's this weird way that we can write this whole sentence much more compact, and it's by putting a triangle in front of a y. This triangle is actually like a Greek delta, and it means change in. So this says the change in y. The change in y. Knowing that, we can go ahead and say, all right, the change in x. The change in x. These changes you will often hear referred to as the rise over the run. The rise is our change in y's because it's our up-down movement, and the run is the change in the x's because it's our left-right movement. Always typically to the right, just a heads up. Now, on a graph, the slope describes the steepness. It means how fast something is growing or shrinking. So for instance, this line is very steep. This line is not. Vice versa, this is also a very steep line, but in a negative direction. This line, less steep, but also in a negative direction. I know that sounds very confusing right now, but we're going to be talking about it ad nauseum, so ridiculous amount of time over the next few days and weeks. You're going to know it like the back of your hand at some point. So to find the slope of a line, we're going to compare the vertical change. Vertical change means our up-down change, which is our rise, to our horizontal change, which is our left-to-right movement, which is our run. Now slide on down here with me. We're going to go ahead and take a look at this particular graph. It says identify the slope and the y-intercept. So our slope is our rate of change, and our y-intercept is where we begin. We've talked about that a whole bunch. It's our initial value. It's where we cross the y-axis. All of those things and then some. The easiest thing to identify right off the bat is the y-intercept. We look at our y-axis and we find where our line crosses it. Our line crosses our y-axis at 4, so our y-intercept is 4. If we wanted to write it as a coordinate point, it would be 0, 4, because all y-intercepts have x is 0. Now, to find the slope is a little trickier. We need to first, so step 1, slope, we need to identify 2 good points. Good points mean that they're points we can tell what they actually are. We've put points on the graph here for you, so I'm just going to highlight the 2 points we're going to do. Step 2, find your rise. So our rise is our up-down movement, and we read all graphs left to right. So that means that we would start here and end here. If we start here and end here, that means we went up how many and over how many to end up there. If we can only walk in straight lines, right? If we can't walk diagonally from here to here, and we can only walk in straight lines, we can walk up and right. If we were to do that, we would walk 1, 2, 3 units up. So our rise is 3. And right, we would move 1, 2 units right. That would be our run. If it's hard for you to count them as you move, you can make those little bubble steps that we made on our graph yesterday with the cat and the mouse, if it helps you count. Now our slope is our rise over our run, which means our rise, we rose up 3, and we ran over 2. So our slope is 3 over 2. If you think you're going to forget whether it's rise over run or run over rise, always remember, if you want to run somewhere but you're sitting in a chair, can you run there while sitting, or do you have to rise up before you run? So you have to rise before you run. You can't run from a sitting position. It's not possible. All right. Flip it over. Oh, sorry. Before you do, let's talk about this guy. 3 over 2 is a slope of 1.5 in decimal form. Now, sort of like scale factor, slopes that are greater than 1 become more steep. Slopes that are less than 1 become less steep. It's like a reduction. They don't grow as fast. But you'll kind of see that as we go through these and we discuss a little bit further. Flip. All right, everybody should be looking at the inside. Periods 1 and 4 should be picking up here. This is where we're left off. Now, number 1 says determine the slope and the y-intercept of the graph. So let's go and look at number 1. The slope and the y-intercept. We know that the easiest one to find is the y-intercept. It's where it crosses the y-axis, which is right there. This is our y-intercept, and we often call it B because it's where we begin. So the y-intercept, or B, is going to be -1. We can also write this as B equals -1. Now, to find our slope, we need to first identify 2 good points. So we're going to identify 2 good points. I'll choose this one. So this will be our first point, and I'll choose this one as our second point. Then we need to say, okay, if we can only walk in straight lines, we need to rise and run. So we rise up 1, 2. That's our rise. And then we run 1, 2, 3, 4, 5. Now, yes, each box counts as just 1 here because we're going 1 by 1. So our slope, which is rise over run, we know is going to be 2 over 5. Now notice, this is a number that's less than 1, which means this line is growing slowly over time. Now what do you notice? Well, before we get into that, we'll answer the one on the bottom. Is the graph proportional or non-proportional? Remember, to be proportional, you have to pass through 0. So does this line pass through 0? No, it passes through -1. So this would be not proportional because it doesn't pass through 0, 0. Done. That's all you have to say. Now let's try the next one. What immediately do you notice is the difference between this one and this one? This one is increasing. If you were to think about money, reading graphs left to right, wouldn't this be good for your money? Wouldn't you be getting more money over time? But here, is this good for your money or bad for your money? Well, reading graphs left to right, this would be going down, so you would be losing money over time. Now let's see what this does to our slope. Before we jump there, let's go ahead and visit our y-intercept. What is our y-intercept, or our B? Well, it crosses the y-axis at 0, so the y-intercept is 0, or we could say B equals 0. Now for our slope, our first step, pick 2 good points. Aren't you guys lucky ducks? I gave you 2 good points right there. Now notice over here, when we rose, we went up 2. Here, are we going to go up or are we going to go down? We're going to first go down. We're going down 1, 2. If we're going down 2, that means that our slope is going to be a -2 because we're going down 2. And I'll even write down 2. Now we're still moving right, so we're going right all the way to here. So we go 1, 2, 3, 4, 5, 6. Now we have our rise and our run. So our slope is 6. I lied. Our slope is -2, which is our rise, over 6. Now we can simplify this, and we must. This becomes -1 over 3. So our slope is -1/3. Sorry guys, I'm a little tongue-tied today. All right. Using this information, we can say that this graph is decreasing over time very slowly, because it's like for every 1 meter, 3 seconds pass. So it's like you're running at a really slow pace. This graph, is it proportional or non-proportional? Well, this graph is proportional because it passes through 0, 0. So we'll circle proportional, and we'll say because it does pass through 0, 0. So right away, some differences you should see, that's a positive slope, that's a negative slope. This is increasing, so it's positive, decreasing, so it's negative. Not proportional because it doesn't pass through 0. This one is proportional because it passes through 0. Now, if you're listening to the video right now, I want you to put a star next to number 2. Thank you. All right, let's slide on down to number 3. North Shore Middle School is tracking the ticket sales of the Little Mermaid production. The results are shown below. Here we go. We have a graph. We want to look at what we have first. So we have the number of tickets on the bottom. We see we're going 2, 4, 6, 8, but that really means we're going by ones because that's 1, 3, 5, 7, 9, right? On the side, we want to see that we're jumping by 10, which means every block represents 5. Now, this is important to keep in mind while we're talking about the slope. Our first question says, using the graph, what is the rate of change? We're too smart for this question, and we know that the rate of change is the slope. So we need to know the rise over the run. Here, we're going to pick 2 good points. We've got this one, we've got this one. I like those, I'm good. We're rising. Now remember, each block represents 5. So we're going 5, 10, 15, 20. So what did we rise? We rose 20. Each block on the bottom represents 1. So we run 1, 2, 3, 4. Now we have our rise and our run. Our rise is 20, our run is 4. Let's go ahead and simplify that. That becomes 5 over 1. Then it's really challenging. It says, what does this mean in the context of the problem? All that's asking you is, what does this represent in this situation? Remember that this is the change in y, and that is the change in x. Therefore, we're going to look at our axes to help us. That means that we have 5, what's our y-axis? Cost, dollars. So $5 per, what does our x-axis represent? 1 ticket. See how we use our graph to help us? So the slope, or the rate of change, means it's $5 per 1 ticket. I hope that works. Okay, slide. Oh no, the hot tub's water heater is broken, and the graph below shows that. Now let's take a look at our graph. We got tank temperature, we have temperature Fahrenheit. All right, cool, we got 82, but whoa, how did we end up at 72? This little guy here means that we skipped a bunch, and that's okay. It doesn't really matter. It's just showing us that we skipped a whole bunch in order to see the graph a little bit better. Our time in hours is on the bottom, so we're going 1. But what happened? We're not going 1 each time. We're skipping, so every 2 is 1. So every 2 blocks is 1 hour. On the y-axis, we're going from 72 to 74. Well, how do we do that? Oh, wait, we're actually going by ones. That's 73, 75, 77, 79, 81. So this axis, we're going by ones. This axis, it's like every 2 is 1. But we don't care. It's saying, what is the rate of change? We know that the rate of change is our slope, and therefore we're going to pick 2 good points. I don't know. I'm going to pick this one and this one. It doesn't matter which 2 you pick. You're going to get the same answer no matter which 2 you pick. Now our rise here, are we going up or are we going down? Hopefully you said we're going down. As you can see, this is a decreasing relationship over time, so we already know that our slope should be a negative. So we're going down 1, 2, 3, 4. And I know I'm going down 4 because this axis is numbered by 1. So each block represents 1 degree. Now our run is a little bit different. We're going all the way from 1 second to 3 seconds. So our jumps are really going to be like 1, 2, because every 2 blocks represents 1. So our rise is -4 because we went down 4, and our run is 2. Simplify this, we have -2 over 1. Now, what does this rate of change mean in the context of the problem? Again, we're going to use our axes to help us do that. That's the change in y, which means it's degrees Fahrenheit. So we have -2 degrees Fahrenheit, and then we could say every, right, some kind of rate of change thing, or per, or for every, or for each. Any of those are all useful. Now this 1 is our change in x. Our x is time in hours. So -2 degrees every 1 hour. You can also say something like drops 2 degrees Fahrenheit per hour. Lots of different ways you can say this, and no, we don't care which way you say it, as long as you don't say drops -2, because that's a double negative. We don't want any double negatives. All right, guys, thank you so much for watching the video. I hope it helps, and we'll see you tomorrow.